Industrial Mechanics and Maintenance Technology. What a mouthful, but what does it mean? Industrial Mechanics and Maintenance Technology, or IMMT, it can't be summed up in just a few words. And if you don't have any history with industry, it's going to be very difficult to wrap your mind around what all is involved in this career path. Hi, I'm Brian Lum. I'm an instructor in the IMMT program here at UACCM. And to explain to you what IMMT is, I decided to give you a visual of the training that you'll get here to secure yourself a position in this field. First, we need to understand this is career training. So we need to look the part and act the part. All of our technical students will be required to wear uniforms. The IMMT uniform will be the red UACCM work shirt with the ID badge. They will also be required to clock in and out of all lecture and lab activities. This is how we will take our attendance. And it's also like you have a job. You'll clock in and out of that job. Third, we have to understand that there are many hazards involved with mechanical and electrical systems. So we need to learn the safety precautions and safety habits to make ourselves a safe workplace. In your first semester, you'll also be trained on how to read schematics and prints. You'll also be trained on personal protective equipment and when it's necessary, such as safety glasses. You'll be trained on arc flash, the hazards associated with it, and the proper equipment to help protect yourself from those hazards. You'll also learn lockout, tagout, which will isolate any energy source from you being injured while working on equipment. And you'll also get your OSHA 10 certification. Now, to learn about the fundamental properties of mechanical and electrical energy, we will have lectures where we will learn about the sciences and the math and theories behind these. Then we will apply that knowledge to basic labs such as testing capacitors, series and parallel circuits, learning about voltage drops and current. We'll also test resistors and learn about their duties and components. We'll learn about fuses and circuit breakers. We'll learn proper rigging procedures, again with the personal protective equipment. And then we'll learn about measuring devices. With measuring devices, we will get you certified in multimeters and the clamping multimeter. So now we have finished our first semester and we have earned a certificate of proficiency. So we've learned how to protect ourselves from the hazards of electricity and mechanical means and learn safe working practices. So now it's time to bring that to hands-on training. All of our trainers have multiple safeties in place to help protect you. But along with your safety procedures that you've learned and these trainers, you will have a safe and educational learning environment. In motors and system controls, we're going to utilize the knowledge that you gain from learning how to read schematics and prints. I may give you a print and you will wire up components like those that are used at companies to produce their product and make it working machine. Or I may give you a description and you will design an electrical print and then wire up those components and have it operate and do these desired means. In this motor and system controls lab, I have tasked the student with designing a multi-conveyor system. The task was to have 3 conveyors. They need to independently start with a delay in between each conveyor. It needs to be a 3-phase system and it also needs to have a seal circuit. The seal circuit will mean that the operator can press start and then walk away from the machine and it will stay running. In your first year, to receive your technical certificate, you'll also be required to take hydraulic and pneumatics. In the hydraulic and pneumatics course, you'll learn about fluid and pneumatic systems. You'll begin the semester out learning on these trainers. These trainers will help you understand the components and the relationship to one another. You'll also understand the relationship between pressure and flow. After you get done with these trainers here, you'll move to making your own hoses using our clamping machine, and then you'll also thread your own pipe. We use hand threaders and auto threaders to make our own pipe. The second half of the semester in hydraulics and pneumatics, you will be disassembling and reassembling hydraulic components, such as cylinders, different hydraulic pumps, reservoirs, and hydraulic pump and reservoir systems. After you have completed your technical certificate, you will begin your second year of training. In your second year of training, you'll be introduced to welding, HVAC, and computer networking. You'll also be introduced to PLCs, CNCs, VFDs, robotics, and automation. Here we have PLC, programmable logic controls. Programmable logic controls are used for automatic systems. A good example of that would be an automatic car wash. When you go up, you'll put your money in and then it will give you a selection. You'll choose that selection. It'll tell you to pull in to a certain point. There are sensors that know when you're in the correct spot. Then there are also sensors in this machine that go back to a computer that tells the machine whether you're in a Prius or if you're in a school bus, and it'll make that adjustments to wash that vehicle. PLCs will use math commands, counters, and timers, and the students will learn to use these programs to make a machine. They will write their basic program on their laptop, and then they will download it into their PLC. On their PLC, they will wire up these components and then operate it as if it's a piece of machinery. Here the student has done a conveyor. This conveyor allows products to go down and it comes to a sensor and it will stop. When it gets to that stopping point, there's an indicator light, a yellow indicator, letting the operator know that there is a component there ready to be picked. If the operator does not take the part off the conveyor within 5 seconds, a red light will begin flashing to sense an urgency. Now these are medical gloves, so we don't want any metal in the product. So we have a proc switch wired up onto the system that if it detects any metal, it will give an alarm so that that operator knows to take that product out and throw it away. And in your last year, you will learn about VFDs, variable frequency drives. We use these a lot in industry to slowly speed up a machine. The conveyor that we saw in the PLC video, it began at full speed. Sometimes we may need it to slowly get up to speed, like when you're in your automobile and you come to a stop sign. When you take off from that stop sign, you don't immediately start at 55 miles per hour, you slowly get up to speed. Let's use a crane that's picking up a molten pot of metal and bringing it to another end of a facility. When it picks it up and it goes to move, it doesn't want to move at full speed right away, otherwise it's going to get a pendulum effect and potentially spill that molten metal in the factory. So what it wants to do is pick it up and then slowly get up to speed. The way we do that is with a VFD. A VFD will bring in AC current and bring it through a full bridge rectifier, transferring it into DC voltage, then sending through IBGTs that will convert it back to an AC voltage. When we convert it back to that AC voltage, we can control the frequency, and the frequency is what controls the speed of the motor. So we can program it to slowly go up to speed. In this example, I have a conveyor that I have on a VFD. I want it to get to full speed after a 15-second delay. So after the machine has started, it will slowly start ramping up speed until it is at 100% speed. Also in your second year, you will train on these individual trainers. Each one of these trainers replicates different motions that you'll see in industry. They'll have PLCs, they'll have pneumatic actuators, cylinders, and several different sensors. I will give errors or make adjustments on there so that the trainer does not operate correctly. As a student, you will go and look this over and make adjustments and troubleshoot the situation to repair it back to its working order. These systems will use pneumatic. They'll use pneumatic through Venturi for vacuum. We also have HMI controls here to give you an introduction into that field. We will also train you on CNC, computer numeric controls. We're going to teach you how to do a program on a very basic CAD program so you can get a kind of an understanding of it. You'll go in, you'll do your design, and then you'll transfer it over into a file to download into the CNC machine. Once you get your file completed, you'll run it through a simulator to make sure the cut looks good. At that point, you'll bring it to your machine, you'll download it into the machine, and then you'll run it. After you're done running it, you'll check your product. You'll make sure that it's to your satisfaction. If it's not, you'll go back to your program and make adjustments to your drawings, and then repeat until you have a satisfied, complete product. So we have done our drawing, and we've converted it and downloaded it into the machine. So in the machine, we will learn how to home it and how to download this program into the pendant and then run it. To finish out your training, you'll take a course, electromechanical troubleshooting. In this course, we tie up all the loose ends, things that we haven't covered, like drilling and tapping a hole. We'll also learn torque specs on fasteners. We'll learn how to align sheaves, pulleys, and sprockets using laser alignment and straight edge. We'll also learn tension on belts. We'll also troubleshoot motors, learn how to mega motor and tear apart and understand the internals of single and three-phase motors. We'll also learn to bend conduit. We will learn about bearings. We'll be able to identify different bearings and their uses. We'll be able to identify fatigue of bearings and failures. We'll also learn to identify different gears and be able to protect them from wear and tear. We will also PM all of our equipment in our program. PM is preventative maintenance. On your automobile, you change the oil to prevent the motor from breaking down. That's what we're going to do on all of our equipment. It is a huge part in maintenance and being able to understand the cycle of when things need to be done. So all of our equipment is PM'd by our students. They'll learn on what intervals to change air filters, to change out oils, to lube chains, to tighten belts, and etc. And this will give you great experience for whenever you go into your career. You will also learn to inventory all of our components. The inventory will also include wear and tear so that we can predict when we need to replace those parts. That's also a very vital knowledge set that you'll need whenever you go into the field. You don't want a machine breaking down while in production. So if you know when a part wears out and needs to be replaced, you can schedule it, and it helps production immensely. With robotics becoming more and more common in the workplace, more and more companies are finding themselves needing highly skilled technicians to be able to program, maintain, and PM these highly sophisticated pieces of equipment. We've been very fortunate. Tyson has donated an ABB robotic trainer for our use in our course. We also have a Lincoln Electric FANUC welding robot that we also train the students on. In robotics, the student will learn how to write programs using the instructions. They'll also learn how to save programs, load programs, edit programs, and also make adjustments to points. They'll also learn about work objects and tool center points so that these robots will operate and function the way desired. Both robots have a program loaded into them. The ABB, this white one here, will be in automatic mode, and it will just work in a rotation as if it's on an assembly line 24 hours a day, 7 days a week, and it will just continue on. The welding robot is as if I have loaded a piece of metal into it. It is going to weld up the part, and then the operator will remove it and put the next piece in for it to be welded.
For more information about the IMMT program, go to UACCM.edu.